Here we are going to do one questions based on midpoint theorem. So let's understand what is midpoint theorem first before proceeding to the questions. The theorem says that in a triangle, right? It's true for a triangle, not for any other figure. That in a triangle, if we join the midpoints of two sides, let's say if I take here P being the midpoint of one side, Q being the midpoint of the other, that is AC, and if you join this line, then this length, this line PQ will be parallel to the third side, that is BC. PQ will be parallel to BC, and the length of PQ will be half of BC. So this is the property on which this question is based. Now let's proceed with the question. It says that ABCD is a rhombus and PQRS are the midpoints of side AB, BC, CD, and DA respectively. So what we need to do is to make a rhombus first. Let's say if I make a rhombus, I have made a rhombus here. And let's say if I name this figure as A, B, C, and D. And I'm now going to join the midpoints of these sides. Let's say if I join the midpoints of this side, joining these midpoints, I obtain a quadrilateral. So I've obtained a quadrilateral. I'm naming it, say, P being the midpoint of AB given, and after AB it's BC, so PQ, R, and S. Now, once we have made this figure, they are asking to prove this figure PQR is a rectangle. That means we have to prove this figure PQR is a rectangle. Now, as I said, we are going to apply midpoint theorem. So midpoint theorem is applicable only in case of a triangle. So we'll be joining AC first. Now, after joining AC, you can clearly see we can apply midpoint theorem in this triangle, that is triangle ABC. In this triangle ABC, P is the midpoint of AB and Q being the midpoint of BC. So therefore, PQ will be parallel to BC and PQ will be half of, the length of PQ will be half of AC. So let's write down the steps here. First, we'll be writing in triangle. So we'll write here in triangle ABC, P and Q are the midpoints of AB and BC respectively. So by applying midpoint theorem, what we can say that this length PQ is parallel to BC, sorry, it's AC, not BC. PQ is parallel to AC and PQ is equal to half AC. And that is from midpoint theorem. You can write using midpoint theorem. Now, once we are done with this, we will consider the other triangle, say this one. In this triangle, ADC. Over here also, you can see that S is the midpoint of AD and R is the midpoint of DC. Therefore, SR is parallel to AC and the length of SR will be half of AC. So here also we'll be applying midpoint and then we'll say that in triangle ADC, S and R are the midpoints of AD and CD respectively. Therefore, by applying midpoint theorem or by using midpoint theorem, this line SR is parallel to AC and SR is equal to half of AC. Say I can mark this equation 2. Now, when you see this equation 1, right, and this equation 2, you will realize that here both the line, that is PQ as well as SR, is parallel to AC. As you know that two lines which are parallel to the same line are parallel to each other. You can see in the figure as well, this PQ is parallel to AC and SR is also parallel to AC. So we can say that two lines which are parallel to the same line are parallel to each other. That means we can write as PQ is parallel to AC. Same for the equal. The length of PQ is half of AC and SR is also half of AC. So two things which are equal to the same thing will be equal to one another. That means we can write PQ is equal to AC. As you know that when you prove the same pair of opposite sides of a quadrilateral equal as well as parallel, like proving PQ equal to SR as well as PQ parallel to SR, then it becomes a parallelogram. So therefore we can write PQRS is a parallelogram. Now, once we prove any figure a parallelogram and we have to prove this a rectangle, then we try proving one angle at 90 degree. If you can prove one angle of this quadrilateral or this parallelogram as 90, say Q as 90 degree, then it will be a rectangle. The reason is a parallelogram having one interior angle as 90 degree is a rhombus. So let's say what to do in this case. For that, we will be joining its other diagonal, and we can join either BC or AC is already joined, so we'll be joining BD. So we'll join BD in this case. So I've joined BD here, and let's say I name this point, say O being the point of intersection of these diagonal AC and BD. I'm naming this point as M and this as N, and we will prove therefore this figure a parallelogram. And we can use midpoint theorem again to prove this figure a parallelogram. So how is that possible? We'll be writing straight away. We can write MQ as parallel to ON and MQ, sorry, this is MO parallel to QN. So let's understand in the figure, this is MQ is parallel to ON, and likewise OM is parallel to NQ, and the reason will be same here, that is from midpoint theorem. Now, once we have proved this, as you know, when you prove two pairs of opposite sides of a quadrilateral parallel, it becomes a parallelogram. So I can write therefore this figure MOCN is a parallelogram. Once you prove this figure as parallelogram, as you know that opposite angles of parallelogram are equal, so I can write, say this angle is equal to this angle. So I'll write this angle MQN is equal to angle MON. Now, further you should know that this angle MON and this angle MON should be 90 degree, as this is the angle made by the diagonals of a rhombus. You should know that diagonals of a rhombus bisect each other at 90 degrees. So clearly we'll write angle MQN is equal to 90 degree, replacing MON with 90 degree. Why? Because since angle MON is equal to 90 degree, and the reason is diagonals of rhombus bisect each other at 90 degree. This is diagonals of rhombus bisect each other at 90 degree. Now look into this. We have proved here, we have proved this a parallelogram. We have proved this. Say I'm marking this equation as say 3, and over here we proved one angle as 90 degree. So what you can say that a parallelogram having one of its adjacent angles as 90 degree, right? One of its is a rhombus. Oh, sorry, rectangle, not a rhombus. It is a rectangle. A parallelogram whose one angle is 90 degree is a rectangle. Is a rectangle. That is what should be our final statement. Once again, we can say for in the third part, we have proved this figure PQRS is a parallelogram. And next, here we proved one of its angle as 90 degrees. So this angle is 90 degree. And we should know that this is a parallelogram with one of its interior angle as 90 degree, which we proved one angle of this as 90 degree. Therefore, this figure can be called as a rectangle.